Beautiful. The next question is, what happens if I add, whoops, too far. If I add a half kilogram mass, guys, quiet, half kilogram mass to this side. Okay? Now what's going to happen? So what is the new acceleration? What is or are the tensions in the four different lines? Okay? And see, here's the problem we have, and just to address the question you raised, Liz. Here, your method would say, I've got 1.5 kilograms down, but you're not going. That's not the tension that you end up seeing in T3. So you got to be a little careful. But so what's the first step to solving any one of these free body diagram problems? Free body diagram. So we're going to do the following, and we're going to come over here and we'll do M1 G down. I've called that T4. We're going to call this one here M2 G down, and then there's a T4 and then a T1. Okay, is that clear? So the idea here is that I've got a gravity force down, and I've got a tension force down, and I got a T1 coming up. What? That's for this one right here. That one. And then we'll do this one right here. I have a T2 coming up, and I have an M3G going down, and then this one right here. I have a T3 going up, and I have a T1 and a T2 going down. And clearly this guy's not drawn to scale. This should be much longer. But I've run out of space. Okay. And the next step would be to write what's the next step? One mind, the half step. Yep.
Question.
Sure.
Does T1 include the force of T4?
So T1 this is just a free body diagram, right? This is, to answer your question, I'm going to use everything in here to write my Newton's second law equation for that particular piece. So, and this is piece M2, right, has those forces acting on it. I don't know if this is.
I'm talking about the free body diagram on the top right.
Oops.
Oh.
Ask your question again, Sarah.
For my free body diagram for the T3 on the top right.
Yep.
I wrote one of the forces as T1 plus T4.
No. That's T1 takes care of. All this pulley knows is that it's being pulled down on the left by T1 and being pulled down on the right by T2. So, okay. So we're going to write the three equations that we care about in the short term. I'm going to write. Have we defined a direction for acceleration yet? No, right? So what's it going to be? It's going to be down. Which side going down? Left. So that's my acceleration. Again, dotted line to make it clear that it's not a force. So now I can write my three equations. I'm going to write M1A is equal to M1G minus T4. M2A is M2G minus T1 plus T4. M3A is equal to, so we'll come over here now. I've got a T2 coming up, and I have a minus M3G going down. And then I'm going to make note of the fact that T2 equals T1. So I'm going to change this one to T2, right? They're connected by a pulley, so that's a fair assumption. Add everything up on the right and add everything up on the left. M1 plus M2 plus M3 all times A is M1G plus M2G minus M3G, and T2 and T2 cancel out, T4 and T4 cancel out, and so I'm left with an acceleration of M1 plus M2 minus M3 all times G over M1 plus M2 plus M3. And for our numbers, this would be 0.5 plus 0.5 minus 0.5 all times 10 would be 5 newtons over 1.5 kilograms, 3.3 meters per second squared. Everybody agree? And then I can solve for the individual tensions. Coming back to this equation right here, I would write T4 is equal to M1G minus M1A. T4 is equal to 0.5 10 minus 3.3. So what does that give me for, what's 0.5 times 6.7? 3.35.
Oh, okay.
Right?
Okay. You just, oh, you
T,
took that out. Okay.
T2, I'm going to use this equation right here. T2 is equal to M3G plus M3A. And that's going to give me 0.5 times 13.3. And that gives me 6.7 newtons. And then from that, I can get T3 is equal to T1 plus T2. And if I do that math out, I end up getting 6.7 plus 6.7 is 13.3. Did I do that right? I think I did. 13.3, 13.4 newtons. Yes, sir?
For T4, you did M1G minus M1A, and then for T2, you did M2G plus M3A.
Right.
Why is that?
Because in one case I was because the direction of the acceleration was different. I came over here and used this equation, these equations here. So this one here, so for T4, I would have M1G minus M1A. So in essence, because this piece is accelerating downward, it actually doesn't feel the full tension associated with gravity. And we'll talk about that in just a second. Yep.
So when you say that T2 equals T1 on the right hand side,
Yeah. That's just because they're connected by a pulley. T1 and T2.
does that mean
Are
they're
the same string.
or they're the same value?
Well, they have different directions, but the same value.
So when you add them, is it just multiplying?
Just add them together. Yeah. Because if you look at this, I'm looking at this to answer that question. I'm looking at this free body diagram right here. Right. This piece is not accelerating. Therefore, the forces have to be balanced. So T3 up has to equal T1, magnitude of T1 down, magnitude of T2 down. Yep.
I'm just confused by your T2 calculation. Just like how you got the.
So I
like
said,
based off of the-
I came to here, said T2 is equal to M3A plus M3G. I brought that over to the other side.
So what does M2A stand for?
M2A would be is the tension associated is the equation for this free body diagram. Okay?
So
We're not done, but let me just
That
gonna.
doesn't help you solve for any of the tensions that we have,
What?
right?